Okay, so what we're dealing with is solving rational equations. This is a rational equation. When you think rational, think fraction, but specifically we have some kind of variables there in the denominator. I'm a three-step process for this. Solve, rational. It's not how you spell rational. Try not to abbreviate here for my equations. Solve rational equations. Step 1. Factor everything. And set the denominators to 0. So we've been seeing pretty consistently that we need to find out where the denominators are 0 because we cannot divide by 0. That breaks math. Close your computers. Give me your full attention at the screen. Thank you. Let's give that a shot. In this case, I want to factor x cubed minus 3x minus 18. I notice it's a trinomial. So I know I'm going to get 2 parentheses. To form x squared, we need an x times an x. Since my second operation is a subtraction, I know that these signs need to be opposites of each other. One will be a minus and one will be a plus. Now I want to think about the paired factors of 18. Well, amongst those is 6 and 3. 6 times 3 is 18. Also, 6 minus 3 is a negative 3. Since our sum here is negative, we will want more negatives. Checking. X times x is x squared. Negative 6 times positive 3 is a negative 18, but we also have our middle sum here. Inside is negative 6x. Outside is positive 3x. That sums for negative 3. Bless you. So this thing becomes this. All right. Nothing else to factor. We only have constants in the numerators. And over here we have linear binomials. So typically we won't be able to factor those. We might look for a greatest common factor. There's not one between those. They're relatively prime. We got one coefficients. All right. Now I'm going to set all of my denominators equal to 0. I know I can't divide by 0. So setting each one of these guys equal to 0. First I notice I got this x minus 6 twice. I only have to set it equal to 0 once. So I'll set x minus 6 equal to 0. Adding 6 to both sides. Setting the other denominator equal to 0. I got x is negative 3. If you have a question, just write it down and I'll address it at the end. Hope you get a scratch piece of paper out, okay? Even if you just have a question, write it down. These values, they're excluded, and if we did some graphing, they would probably produce those vertical asymptotes. But we're not graphing here, okay? Step 2. Oh, obey, pen. There we go. Multiply by the least common denominator. Multiply by the least common denominator. Well, the least common denominator has what everything has. X minus 6x plus 3 is the least common denominator because it captures the x plus 3 and it captures the x minus 6. The least common denominator has all of the factors of all of the denominators in it. I'm going to now multiply by x minus 6, x plus 3 on both sides. Here I go. multiply by that least common denominator. The LCD is, didn't change, x minus 6, x plus 3. I'm going to multiply by that on both sides. X minus 6, x plus 3, times my left-hand side. You don't need these. I want to clearly show, a bracket is the same as parentheses. I just want to clearly show I'm multiplying by it on the left and the right. 63 over x minus 6, x plus 3. Oh, sorry. Forgive me. Minus 6, open parentheses, x plus 3. That's the left-hand side. Now I'm going to multiply by it on the right-hand side. 7 over x minus 6. Bracket's the same as a parentheses. Times x minus 6, x plus 3. All I'm doing here is whatever I multiply by one side, I got to multiply by the other. Okay? So now I'm doing distributive property. This thing times this one, and this thing times this one. Well, when I multiply this whole thing by this fraction, notice that the what's being multiplied will cancel with what's being divided. That's why we did this. We will be left with only 63. The whole reason we're multiplying by the least common denominator is to get rid of all these fractions. Okay? Now, I'm going to multiply this whole thing by this one. Well, the x minus 3 will cancel with the x minus 3. The x plus 3 will cancel with the x plus 3, leaving 6 times this other factor, x minus 6. The subtraction stays the same. 6 times x minus 6. One more time, from this part to here, this entire denominator is identical to this one, so the thing multiplied canceled with the thing divided to leave only 63. This one here times this one, the x plus 3, cancel with the x plus 3 to leave 6 times x minus 6 on the left-hand side. And I know I told y'all just to save your question, but I'm going to ask for a little input here. When I multiply this right-hand side times this fraction, what will remain? What cancels? Yeah, x minus 6 cancels x minus 6. Everybody see that? So what are we left with? On the right-hand side, x plus 3, what else? Yes. Can y'all see we're left with a 7 and an x plus 3? Those are multiplied by each other. Now, we took that terribly filthy original equation. That original equation had fractions everywhere. It had a quadratic. It looked horrible. And now we have this very nice equation with no fractions. We have simplified this problem substantially. Okay? Last step, 3. Solve. And importantly, is it a quadratic? If it is, we have all of our methods for solving quadratics. Lean towards factoring or the quadratic formula if it's unfactorable. Solve and check. No, I'm just saying, keep in mind, if it is a quadratic, we need to be using factoring in the quadratic formula. But what do you notice about this one, Jacob? Is it a quadratic? No, it's not. This is going to be pretty easy. I'm going to start by distributing. Nadia, on the left-hand side, when I distribute, what do I get? First 63, right? Now what? Very good. Plus 36, because we have a negative times a negative, essentially. All right, then, Travis, on the right-hand side, when we distribute, what do we have? 7x plus... Any questions, anybody? I can combine these two like terms on the left, 63 plus 36. That feels like 99 to me. Now we have variables on both sides. Any of you knuckleheads remember what do we do when there's variables on both sides? Good. Got to get them together on one side. We got to by eliminating one of them. I'm just going to eliminate this minus 6x by adding 6x. Think additive inverse. Doesn't matter which way you go with it. That cancels, leaving 99 on the left. 76 is a 13x on the right. Solving for x, what's the next step? Anybody? Good. Subtracting 21. It's going to leave 78 equal 13x. And dividing by 13, forgive me. I think that's 6. We think x is 6. Okay? Any questions? Now, you got to, lastly, in this part here, the checking is very important. All right? Because sometimes you will get solutions to that new equation that were excluded values that won't actually work because we've altered the way the equation looked like. So you need to actually substitute that 6 back in. So I'll go back to the original. And what do I see? Looking at my original equation, looking at my excluded value, I think the solution is 6. What do you observe there? What about x equals 6? What are these two values? What did we say about these two values again? They're excluded. All right, these two are excluded. We can never be this. Not only is x equals 6 it not going to work, it is just, we can't even put it in at all. So this equation will have no solutions. All right. Okay. So x equals 6 solves this modified one, but since x equals 6 is excluded, what made it excluded again? What makes what equal to 0? What cannot be 0? Good. Since x equals 6 is excluded, it made the denominator equal 0. Can't divide by 0. There are no solutions. All right. What